Hello students and welcome once again, and this today's video is in connection with IBDP course, and the subject is physics, and the topic, as you can see on the screen, it's FBD of objects kept on an inclined plane. In physics, you have a topic called resolution of forces, and many a times the objects which are kept on an inclined plane, those objects, they are uh, acted upon by so many forces, and these forces are to be resolved. Okay, so you have to draw the FBD of objects of the inclined plane which are kept on the inclined plane. Now this FBD is uh, the force body diagram. The full form is force body diagram. The objects normally taken are rectangular in shape, just to depict them, and the inclined planes can be shown either this one, like this one, or like this one. Either case, you are not doing anything wrong, anything mistake is not being done, whether you keep the inclined plane in this way or you keep the inclined plane in this way. The angle of inclination theta is this angle theta. In the left hand triangle, you can see angle B is this inclined plane inclination of angle theta. Here, angle C is the angle of inclination. Okay, so that is always represented by theta. So any inclined plane has an angle of inclination denoted by a theta. Okay, now there will be two cases that we are going to study. One is where the friction is not considered, or it is not taken into consideration. So I have written here without friction, that is frictionless or smooth inclined plane. So these inclined planes are so smooth that there is no friction at all. So we are not going to involve the friction part into this. Okay, so suppose you have inclined plane which is kept in this way. Okay, the left hand side diagram I am first showing you, and the right hand side diagram also I have shown here a parallel. Okay, and you will see that whether it is left hand side or right hand side diagram, it doesn't make any difference. Okay, so right now see the left hand side diagram. So you can see that this is the FBD diagram. This is your FBD diagram. Okay, so on this inclined plane, you can see this object is being placed. The object will have a mass of m. Okay, so first of all, when it is a frictionless inclined plane, the forces that will be acting on this particular block will be the weight of the block, which is equal to mg, that is this one. W is equal to mg, and this weight is always drawn, or it is always shown going vertically downwards, perpendicular to the horizontal. Can you see this will come down? This is the mg force. Okay, W weight force, which is equal to mg. This is always drawn right from the object vertically downwards and perpendicular to the horizontal of the inclined plane. This is the horizontal of the inclined plane, right? Okay, and that is one force. Second force is the object is placed on the inclined surface. Now this is the inclined surface. I'll write IC, IS. IS is inclined surface, right? This inclined surface, the object is kept on this inclined surface. So from the surface, vertically upward going force. Okay, vertically means not exactly vertically, it will be perpendicular to the surface, and that force is always represented by a normal force or a reaction force. So this is your normal force. Okay, this one, this force is the normal force. So first force is the weight force, which is equal to mg. Second force is the normal reaction force, either N or R. and this particular normal force or the reaction force is always going upwards away from the surface in the upward direction, and it is always perpendicular to the surface. Normal is perpendicular to the inclined surface, and the weight force is always perpendicular to the horizontal of the inclined plane. Okay, these are the two forces that comes in picture. And there's one more force, third force, which is either the upward force if you are pushing the block upwards, okay, along the inclined plane, then it will be Fa force. In this case, this is the force applied in the upward direction, or it can be a downward force, right, coming down. Okay, so that is the third force, right? And since we are not considering any friction in this case, otherwise the fourth force which comes in picture is the friction force as well. Okay, but now we are not talking about the friction force. So these are the three forces. So weight force, that is mg, the normal force or the reaction force, and there's a applied force Fa. In this case, the applied force is in the upward direction, so the object is moving up the plane. Okay, can you see the object is moving up the plane? This arrow is showing you object moving up the plane. Okay, now this is the FBD diagram, but still this FBD diagram is not complete. It will be complete. Now we have just shown the three forces which are acting on the body. Now what you have to do is, out of these three forces, whichever forces are inclined, okay, that you have to resolve. Okay, so now this W force, okay, now the frame you are going to choose is this one. Okay, this is the frame. Okay, this is the frame you are going to choose. Okay, this is known as parallel to the inclined plane frame, and this one is known as the perpendicular to the inclined plane frame. Okay, or you can say, normally when we take x and y axis, this is your x axis and this is y axis. If you just rotate this, okay, this by say 45 degree in the clockwise direction, you will get this. Okay, so this parallel is nothing but as good as x axis only, but slightly tilted by 45 degree, and this perpendicular is nothing but the y axis but tilted by 45 degree. Okay, so now we have to take a coordinate axis which is parallel and perpendicular to the inclined plane. Right, so forget this. Now we are going to consider this as our coordinate axis, right, this one. So along this parallel and perpendicular, okay, coordinate axis, you are going to resolve the force which is inclined. Now out of these three, if you see W equal to mg force, it is not inclined. Okay, it is exactly vertical. So this is not inclined. W equal to mg is not inclined, it is vertical, right? Even normal force or the reaction force is vertical, it is not inclined. Okay, so horizontal and vertical forces are not inclined forces. Okay, but any force which is neither horizontal nor vertical will be taken as inclined. So W equal to mg force is vertical, it is not inclined. Normal force or the reaction force is also vertical, it is not inclined. But the third force, that is Fa, okay, that one, no, I'm sorry, this W equal to mg, okay, is an inclined force. Okay, can you see it is inclined, it is going this way, right? So this is in this coordinate axis, it is inclined, but this normal force is actually vertical and the Fa force is horizontal. So this is vertical, mg is vertical, Fa is horizontal. Okay, see, Fa is along the parallel, right? Mg is along this and normal force is along the perpendicular. So these are horizontal and vertical respectively, but this mg force is neither horizontal nor vertical. Now when I say horizontal or vertical, you have to consider that as parallel and perpendicular. So mg is neither parallel to the inclined plane nor it is perpendicular to the inclined plane. So mg is the force which is the inclined force. So that force mg you will have to resolve, and you have to resolve that mg along the parallel direction and the perpendicular direction. So when you resolve this mg force along the parallel and along the perpendicular directions to the inclined plane, then your FBD will be complete. Okay. One more thing you have to remember, that the inclination, the angle of inclination of the inclined plane in this case is theta. Okay. This is your theta. Now geometrically, always in an inclined plane, the angle between the mg force and the normal reaction force extended will also be equal to theta. Can you see? This is also theta, right? Geometrically, you can always prove that this angle of inclination theta, okay, of the inclined plane is also equal to the angle between the mg force, okay, and I'm not talking about the component of mg force, the mg force which is vertically going downwards, and the normal reaction. That angle is also theta. Now you get to see the resolved forces of this mg, one which is parallel to the inclined plane, that is this one, and one which is perpendicular to the inclined plane, which is this one. This is the parallel one, okay. The first one is parallel to the inclined plane, and the second one is perpendicular to the inclined plane. Can you see? This component is going perpendicular to the inclined plane, and this one is going parallel to the inclined plane, okay. And normal resolution of force, you must have studied that this particular parallel component is away from this angle theta, so we are going to take that as w sine theta, and this perpendicular component is attached to the theta, so we'll take that as w cos theta. So your perpendicular component is going to be w cos theta, and your parallel component is going to be w sine theta. Once the two components of this inclined plane is also drawn on the FBD, now your FBD is complete. So this is how you have to draw the FBD diagram of such questions where a block is kept on an inclined plane. Is that clear? Now on the right hand side, I have shown you the same thing. Only thing is the inclined plane I have flipped out. Okay, so here the inclination of angle, the angle of inclination was on the right. Here the angle of inclination is on the left. But that doesn't make any difference really. Okay, so once the FBD is ready, okay, then you have to apply the principle of equilibrium. Now this block is neither going into the inclined plane nor it is flying off from the inclined plane. It is remaining on the inclined plane. Therefore the forces which are acting along this vertical frame, okay, will be equal. So along this vertical frame you have N, that is the normal reaction force going upwards, and downwards you have the perpendicular component of mg, which is nothing but w cos theta. Is that clear? So you can write N is equal to w cos theta because they are equal to each other. So N equal to mg cos theta. Is that clear? So normal reaction will be equal to mg cos theta, which is the perpendicular to the inclined plane component of mg. Right? Now, if you see the parallel components, you will see one component of mg going downwards, okay, that is w sine theta, and you have another force, that is applied force, going upwards, that is Fa. And you know that this particular body, this object, is moving in the upward direction. Therefore you can say that Fa is a more dominant force and Fa will be greater than w sine theta. So can you write Fa greater than w sine theta? So this is what, these two statements is what you can derive from this FBD. So normal reaction is equal to mg cos theta in this case, and Fa, that is the applied force with which you are pulling the block in the upward direction, and the block is moving in the upward direction along the plane. So that force Fa will be greater than W sine theta. W sine theta is a force which is going to pull down the block. Okay, it is going to pull the block down the slope, but then your Fa is greater than W sine theta, so the block is ultimately going to go up. Is that clear? So this is what I wanted to explain you about object moving up the plane and the FBD diagram of that object. Now whether it is this way or it is flipped in this way, in both cases you will get the same thing, that is n is equal to mg cos theta and Fa will be greater than W sine theta. So you should practice both the ways of drawing these FBD diagrams. In both these diagrams, okay, this was a case of a frictionless inclined plane, so we did not consider the friction. Okay, now in the second case we are going to consider friction. Okay, so suppose this inclined plane is such that it is not a very smooth one, or you can say it's a rough inclined plane. When it is rough inclined plane, then it will have some coefficient of friction value, that is mu s value will be there. Okay, so whenever mu s value is there, you will also have one more extra force apart from these three forces that we dealt with in this. Okay, we dealt with three forces, 1, 2, 3. In the friction case, there will be one more force added up, and that fourth force will be the friction force, small f. Okay, friction force. This friction force is always given by a formula which is mu s, that is coefficient of friction, static friction, multiplied by always the reaction force or the normal force. Okay, so the friction is always a product of the coefficient of friction and the normal force or the reaction force. So remember, this is the fourth force which will be coming in picture. So going by the same line, suppose you have an inclined plane and this is your angle of inclination theta, and if you draw this block placed on the inclined plane, but now this block has some value of friction as well because it has some mu s value. So frictional force will always be in the opposite direction of the motion of the object. Now this particular block is also going up the plane, so the Fa is greater than W sine theta in this case also, because the block is moving in the upward direction. But now in the downward direction, that is opposite to the movement, opposite to the direction of the moving object, you will always have a force called frictional force, which is equivalent to mu s into normal force. Okay, so that you will have to consider. So in this second case where friction is involved, your vertical forces will be normal force equal to mg cos theta. Okay, this will be mg cos theta as usual. But your horizontal forces, there you will have Fa. The object is ultimately moving in the upward direction, so Fa is the dominant force. So Fa will be greater than not only W sine theta, but now W sine theta plus frictional force will also be there. So F plus W sine theta will come in this picture. Okay, what is this F? F is equal to mu s into R. So you can write that the applied force F has to be greater than your frictional force, which is equal to mu s into R, plus the W sine theta component. This W sine theta is the parallel component of the weight force, that is W force. Okay, so this is how you have to understand the FBD of a block kept on an inclined plane when friction is involved. Okay, and as I told you, if you flip the inclined plane in this way, still nothing changes, everything remains same. N will be equal to mg cos theta and Fa will be greater than W sine theta plus F, where F is equal to mu s into R. Okay, here also you will have Fa greater than W sine theta plus your frictional force will be mu s times R. Can you see this particular quantity remains the same? Okay, whether you flip or you don't flip the inclined plane. Okay, So both the way you have to practice. Okay, so that was all about how to draw the FBD of an object placed on the inclined plane. Now let us consider one example, numerical. And this numerical, you can see the diagram over here. And let me read out what the question says. Now, according to the diagram, the inclined plane, this is the inclined plane, and the angle of inclination theta is 30. So this is your theta, 30 degree. Okay. And this is a body whose mass is given to you as 10 kg. This is a 10 kg mass. So the question is over here, right? Body of mass 10 kg. This is the body of mass 10 kg. It is sliding down the surface. Now this body is sliding down. It is going in the downward direction, right? It is sliding down okay, down the plane. It is moving in the downward direction. So it is sliding down the surface at an angle of theta. This surface is at an angle of theta, okay, and theta is 30 degree. Okay. Now what is the question asked? You have to calculate the acceleration A of this body. Now this body is sliding down. So the mass of the body is 10 and the acceleration will be ma. Okay, F equal to ma is the formula. You know that F is equal to ma. So the body mass is 10 kg. Okay, this F, that is the downward force, you will have to calculate. Okay, and after calculating your downward force, you will have to find out this acceleration. So what is the acceleration with which the body is going down, which is the body is moving down, that you have to find out. Okay, and what all things are given? Mu k is given to you. Now what is this mu k? Mu k is nothing but, as I told you in the explanation of this FBD on the inclined plane, I used mu s. Mu s is the coefficient of static friction. Okay, when the object is not moving, okay, it is known as static friction. And mu k is the coefficient of kinetic friction. Coefficient of kinetic friction. This is when the body is actually moving or it is sliding. In this case, it is sliding down with some acceleration. So you will have to consider mu k and not mu s. So mu k value is given to you as 0.5. Okay, so mu k, which is coefficient of kinetic friction, is given as 0.5. Okay, and here the frictional force, the kinetic frictional force Fk, will be mu k multiplied by the reaction force. Okay, this formula is also, you are going to use this formula as well. Okay, and he has told you to take G as 9.8 meter per second square. So with all this information, let us try to understand and see how you can calculate this acceleration. First of all, you try to understand the diagram. So this is the inclined plane where the angle of inclination theta is 30 degree. And this is a body kept on the inclined plane whose mass is 10 kg. And the weight of this particular body, that is mg, will be this. And it is shown going vertically down perpendicular to the horizontal, right? So this is your W force. W is equal to mg, right? This vertical force going downwards, okay, is also known as the force of gravity, because that is the weight of the body. Okay, so it is also known as force of gravity. Many a times it is also shown by the sign Fg, force of gravity. So whether you call it force of gravity Fg, whether you call it W, all means one and the same, but that will go vertically downwards perpendicular to the horizontal. Okay, so that I have shown here. Okay, now the normal reaction, this force is always acting perpendicular to the inclined surface. Now can you see this is perpendicular to the inclined surface? This force, reaction force, is perpendicular to the inclined surface and it is moving outward. Okay, it is going outward, okay, away from the surface, right? Away from the inclined surface, right? So this is your reaction force, this is your weight force mg, and this mg force, you know, you are going to resolve it along two directions, that is parallel to the inclined plane direction and perpendicular to the inclined plane direction. So this force mg, the parallel component will be this one. Can you see this one? And the perpendicular component will be this one, right? So this is your parallel component will be mg sine theta. Now why sine theta? As I told you, this theta, angle of inclination, is also the angle between the mg and the normal reaction. Can you see this is normal reaction? Now this normal reaction, if you shift it at this particular position, okay, this is normal reaction. So the angle between the normal reaction and the mg force is also theta. So this is theta. So this is 30, right? Now this component is attached to this angle 30. Okay. So this component you are going to take as cos. Okay. So this is your mg cos theta. Now this is what component? It is going perpendicular to the inclined surface. So this is your perpendicular component of W. Okay. So perpendicular component of W will be mg cos theta. And this component is going parallel to the inclined plane. So this will be your parallel component of W. So once you prepare this parallel and perpendicular component of W, your FBD is ready. Now what you are going to do? Now first, your aim is to find out this acceleration, right? So first let us try to find out R, because we are left with this force Fk, that is the kinetic frictional force Fk. Can you see this force? This force, kinetic frictional force, will always be in the direction opposite to the direction of the movement. Now the block is sliding downward, so your Fk will be in the opposite direction, in the upward direction. This is your Fk. And this Fk is always equal to mu k times the reaction force. Okay. So you will need this Fk value. It is not given to you, so you will have to find out Fk value. Mu k value is given to you. It is 0.5. But you don't know the reaction value. Okay. So to find out the reaction value or the reaction force, what we will do, we will consider the vertical forces, the summation of vertical forces to be 0, because that is in equilibrium. Right. So this vertical forces can you see in the diagram, the vertical forces consist of R, which is going in the upward direction, and in the downward direction you have the perpendicular component of the weight, that is mg cos of 30, right? So these two are in the equilibrium position right now, because the block is neither moving in the upward direction or in the downward direction on the plane, on the inclined plane. It is not moving, it is stationary. So these two are equal. So you can write that R is equal to mg cos 30. So you got R is equal to mg cos 30. So your Fk, that is frictional force, will be equal to 0.5 times mg cos 30. Understood? So your frictional force will be 0.5 times mg cos 30. Now this is what I have written here. Fk will be equal to the frictional force, that is kinetic frictional force, which will be equal to mu k multiplied by R. Right? Now, I am this R value we will find out later. It will come in picture, right? So just try to understand this terms. W is equal to mg is always vertically downwards perpendicular to the horizontal. This is understood. R is always vertically upwards perpendicular to the inclined surface. This is understood. Fk is the frictional force, which is always equal to mu k, that is coefficient of kinetic friction, multiplied by reaction. This is also understood. Now look at the resolution of this mg. W is equal to mg force, which is going vertically downwards, can be resolved into this force, that is perpendicular to the inclined plane, and that will be W cos theta. Okay. And the parallel component, parallel to the inclined plane component, will be W sin theta. So that I have written here. W cos theta is your perpendicular to the plane component, and W sine theta is parallel to the plane component. Is that clear? Now, let us try to understand this. Summation of Fy equal to 0. This is from the condition of equilibrium that you get. Okay, summation of Fy equal to 0 I have written. Why? Because in the vertical direction, the object is not moving at all. It is stationary. So summation of Fy will be equal to 0. Normal reaction is in the upward direction, which is taken as positive. And mg cos theta is in the downward direction, which is taken as negative. So summation of Fy will be plus r minus mg cos theta, and this should be equal to 0. So this is what you can write. For summation of Fy is equal to 0, you can write r minus mg cos theta equal to 0. And if you take this mg cos theta on this side, you will get r is equal to mg cos theta. Okay, you know all the values. M is 10 kg, g is 9.8, theta is 30. You know all the values. So you have got the value of reaction now. Okay, but I am keeping as it is right now. Okay, we will directly find the A. So this r is equal to mg cos theta. Till here you must have understood. Now r will be equal to, when you plug in the values, m will be 10 kg, g will be 9.8, and cos of theta, theta will be 30. So you are going to get this equation 1. So r you have already got. Once you have got r, you can get this Fk also. What is this Fk? The kinetic frictional force. What is the formula? Coefficient of kinetic friction multiplied by r. So can I write this as Fk is equal to mu k, that is coefficient of kinetic friction, multiplied by r, and r I am going to write as mg cos theta. So I get this equation. Okay, so I get Fk also in terms of mu k times mg cos theta. Okay, now coming to, this is from the vertical forces that I got. Now come to the horizontal forces, or you can say the parallel to the plane. Now this was the inclined plane. So parallel to inclined plane, what all forces you have? On this, in this direction you have Fk, and in this direction you have the parallel component of the weight. And what is that parallel component of the weight? It is mg sine theta, right? Okay. So now you see that the object is actually moving down the plane. Okay, and because the object is moving down the plane, okay, so there is some force acting on the object, and that is the reason it is moving down. And because it is moving down, and because it is moving down due to some force, the acceleration is also there in this particular object. So mass into acceleration is always equal to the force, net force acting on that body. So this body of mass m is acted upon by some net force, okay, or you can say imbalance force, okay, net force or imbalance force. Okay, and due to this net force or imbalance force, there is some acceleration in the body. So that acceleration you are supposed to find out. So your formula you are using is ma is equal to F net. Now what is this F net? F net is the net force of the parallel direction, parallel to the inclined plane. In the parallel direction, you have two forces. One is Fk. Now this Fk is going on the right, so that you will have to take as negative. And this mg sine theta is going to the left, so you will have to take that as positive. So this net force, where I have written net force, yeah, this is I have written here, Fx net force is equal to ma. This net force will be equal to ma, and this net force will be equal to mg sine theta, positive mg sine theta, minus Fk. Okay, because Fk is going in the opposite direction, and the convention is on the right, the force, frictional force going on the right, you are taking as negative, and any force going on the left or downwards is taken as positive. So your net force will be mg sine theta minus a Fk. Now Fk, you can substitute this value, okay, this value. So ma will be equal to mg sine theta minus, instead of this Fk, you can plug in this value, mu k into mg cos theta. Now from this equation I can cut m, and m. Okay, and I'll be left with A equal to G. Now G I am taking common out, and I'll be left in the bracket with sine theta minus mu k times cos theta, and I got the formula for my acceleration. So acceleration I am getting as G times sine theta minus mu k times cos theta, and once you plug in the values you can get the A value. So G I am taking as 9.8, theta I am taking as 30, so sine of 30. Mu k is given as 0.5, so I am taking mu k as 0.5. Again, this theta I am taking as 30. So my A value will be 9.8 bracket sine 30 minus 0.5 times cos 30. And if you do this calculation on your calculator, you will get the acceleration as 0.656 meter per second square. This is how you have to find out the acceleration of a body which is sliding down an inclined plane, and you have made use of all the concepts of the FBD applied on a body kept on the inclined plane. So this is how you have to deal with this problems based on objects placed on inclined plane. So the more you practice this type of questions, the more you will get your mindset on it. And IBDP physics is really, I will not say it is tough, but then you have to work very hard and you have to solve more and more problems to get the real sense of it. Okay, so that was my today's video on IBDP physics, and the topic chosen by me was the FBD diagram of the object placed on the inclined plane. Okay, that's all for today. See you in the next video, and I'll be coming with some new concept. Bye. Take care, all of you.